So, basic nature of amines is due to the presence of lone pair of electron on the nitrogen atom, and according to Lewis acid base theory, the substance which donate the lone pair of electron, they are called Lewis base. So, amines are basic nature because of lone pair of electron present on nitrogen atom. So, this amine molecule, they can share the lone pair of electron on nitrogen with an electron of deficient species. This lone pair of electron, they donate towards which atom? The electron deficient species. For example, trimethylamine share its lone pair of electron within the electron deficient boron trifluoride. For example, this Me3N trimethylamine react with Bf3 boron trifluoride, and this nitrogen atom or this lone pair of electron, they shift towards boron or electron deficient atom and to form Me3N plus Bf3 minus. So, this is the donation of a lone pair of electron, as they are basic in nature. So, look at this chart. These are the some primary amines, secondary amines, tertiary amines, ammonia and aryl amines or aromatic amines. Those molecule, they are having less pKb value, they are having strongest base or basic strength increases, decrease the pKb value. So, out of these 4 types of amines, look at the chart, the lowest pKb value 3.0. So, this is the strongest base N-ethyl ethanamine, and highest ammonia 4.3, means out of this primary, secondary, tertiary and ammonia, the ammonia is less basic in character than primary, secondary and tertiary amine. And these aryl amines or aromatic amines, they are having highest pKb value. So, these are the less basic character. Why they are less basic character? Because of the lone pair of electron on nitrogen, they conjugate with this benzene ring, they cannot donate the other atom or electron deficient species. So, they are having highest pKb value, means lowest basic character of aromatic amine than ammonia, tertiary amine, secondary amine and primary amine. The basic strength of aliphatic amines, these strengths in the observe the pKb value and basic strength of amines and NH3 can be represented as shown below. The order of pKb value, ammonia, they are having highest pKb value, RNH2 primary amine, R2NH, they are having lowest pKb value than tertiary also. So, out of these 4 molecules, ammonia, primary amine, secondary amine and tertiary amine, according to pKb values, the secondary amine is strongest basic strength than primary and then tertiary. And the order of basic strength, they are also NH3, RNH2, R2NH and R3NH. This R2NH means secondary amine is also highest basic strength than primary, secondary and ammonia. So, ammonia is less basic character than primary amine, secondary amine and tertiary amines. So, why this is possible? Because this is the first factor affecting on the basic character. Number 1, influence of plus effect. So, this out of these 4 molecules, the electron donating group increases. So, they donate the electron or the increase the plus I effect, they increase the basic strength of amines. The order of stabilization, NH4 plus, RNH3 plus, R2NH2 plus and R3NH plus. So, this is the highest stability of molecule. Tertiary amine is more stable than secondary, primary and then ammonia. But expected order of basic character is tertiary amine is more basic than secondary, primary and ammonia, according to this influence of plus I effect. So, which of the following factor does not affect the basicity of amines? Option A, inductive effect, option B steric hindrance, option C resonance, and option D electronegativity of the central atom. So, inductive effect, steric hindrance and resonance, they affect on the basic character of amines. Inductive effect and steric hindrance, they affect in aliphatic amines, also the steric hindrance in aromatic amines. Resonance factor, they affect on aromatic amines, but they do not factor this electronegativity, this factor do not affect on basic character of amines. So, the correct option, option D, electronegativity of the central atom. Second factor affect on the basic character, influence of solvation. Solvation means this amine molecule, they bond with water molecule. So, this NH4 molecule, they bond with 4 water molecules, NH3, RNH3, they bond with 3 water molecules, R2NH, they bond form with 2 water molecule, and this last R3NH, they bond form with 1 water molecule. So, the more the bonding, the more basic character. So, the solvation, they effect on the basic character of amines. The number of hydrogen atoms bonded to the nitrogen decrease from 4 in NH4 to 1 in R3NH. So, in this molecule 4 water molecule bond with nitrogen atom, and in this molecule only 1 water molecule bond with nitrogen atom. As a result, NH4 plus is the best stabilization by solution. Why stabilization by solution? Solution is very poor in R3NH. So, lower or poor solvation and higher solvation due to the formation of bond with water molecule. And third factor, the combined influence of plus I effect and solvation. So, the combined influence of plus I effect and solvation on stabilization of if conjugate acids of aliphatic amines decide the observed basic strength and pKb value. These two influencing factors operate opposite direction. Solvation, more increase or more solution in NH4 plus molecule and lower in R3NH plus. But plus I effect, lowest in NH4 plus and highest in R3NH. So, plus I effect increases from NH4 to R3NH and solvation increases from R3NH to NH4 plus. So, this is the combined effect of plus I effect and solvation. So, basicity of aryl amines, from the pKb values we understand that the aryl amine is generally weaker base than ammonia and aliphatic amines. Because of this NH2 molecule and this nitrogen, lone pair of nitrogen atom, they bond with H2O molecule and they form NH3 plus. So, this is the conjugate acid base molecule, and both the species base and conjugate acid are resonance stabilization, but to the different extent. This molecule also, this lone pair of electron, they stabilize in this electron lone pair in conjugate aromatic system, and this NH4 plus they also they having conjugate system. So, basicity of aryl amines, the lone pair of electron do not available for the donation, hence the aromatic amine is less basic character than aliphatic and ammonia molecule. So, next point, chemical properties of amines. Number 1, laboratory test for amines. Number 1, test for amines as the base. So, primary, secondary and tertiary amines are basic compound, and this basic nature of amines is detected in laboratory by reaction with aqueous solution of strong mineral acids. This diazotization reaction or orange dye reaction or orange dye stuff reaction or test is useful for the detection of primary amines. In this test, the sample of aromatic primary amine, add 1 to 2 ml concentrate hydrochloric acid and aqueous solution of sodium nitrite is added with the cooling, and the solution is transferred to the test tube containing the beta naphthalene NaOH and to form orange dye stuff. So, the formation of dye, orange red dye color. So, this means the formation, this means the presence of aromatic primary amine. So, this test, diazotization test or orange red dye stuff reaction or test is useful for the detection of aromatic primary amine. Next important reaction, alkylation of amines, means Hofmann's exhaustive alkylation. So, alkylation means addition of alkyl group in amines. So, if excess of alkyl halide is used to form tetraalkyl ammonium halide is obtained as a major product. So, excess of alkyl halide react with ammonia and the form of the tetraalkyl ammonium halide, and this the reaction is known as a exhaustive alkylation of amines. So, this is the example or general reaction of alkylation of amines. Suppose this primary amine RNH2 which is react with one molecule of alkyl halide. So, in this reaction, this one hydrogen atom of amine is replaced by this R group and to form R2NH, and R2NH means secondary amine. Then this secondary amine which is react with another molecule of alkyl halide by removing HX molecule. So, this hydrogen atom replaced by this one alkyl group and to form R3N means tertiary amine. But this tertiary amine they react with another molecule of RX. They do not having any replaceable hydrogen atom on nitrogen atom. Hence, this alkyl group or they form the salt molecule R4N plus X minus, and this salt they are called tetraalkyl ammonium halide. So, this tetraalkyl ammonium halide they are also called as quaternary. So, quaternary ammonium salt. Quaternary means 4 alkyl group attached to nitrogen atom means quaternary, and quaternary ammonium halide means positively charged nitrogen atom which is attached to 4 alkyl group and 1 halogen atom. So, this is the quaternary ammonium salt. So, formation of tetraalkyl ammonium halide, and this tetraalkyl ammonium halide is called as quaternary ammonium salt, and this quaternary ammonium salt which is the crystalline formation. Third preparation, third chemical properties, elimination of tetraalkyl ammonium iodide. So, this is the example of tetraalkyl ammonium halide, CH3 CH2 CH2 N plus CH2 CH3 thrice. So, this is the structure N CH2 CH2 CH3 and 3 molecules of ethyl CH3 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 N plus and plus I minus. So, this is the structure of NNN triethyl propyl ammonium iodide. So, this molecule they react with AgOH, silver hydroxide, and this silver hydroxide formation by using this moist Ag2O means moist silver oxide. Moist silver oxide means Ag2O molecule which is react, moist means water molecule, and they form twice AgOH, and this twice AgOH means one molecule of AgOH is used in this reaction. So, in this reaction this iodine atom is replaced by O minus and to form CH3 CH2 CH2N CH3 CH2 CH3 CH2 CH3 CH2 CH3 and O minus. This iodine atom replaced by this hydroxyl group and to form NNN triethyl propyl ammonium hydroxide. So, iodide convert into hydroxide, and finally, this molecule they on heating by losing the water molecule. So, by elimination reaction CH2 double bond CH2. Out of this 3 ethyl group, one ethyl group convert into CH2 double bond CH2 means ethene molecule, and CH3 CH2 CH2 N CH2 CH3 CH2 CH3. So, NN diethyl propyl amine. So, in this reaction the formation of alkene molecule, and every elimination reaction they gives alkene compound. So, this is the elimination reaction of tetraalkyl ammonium iodide. Property acylation of amines. Acylation means addition of acetyl group or acyl group. So, in this reaction when ethanamine or ethylamine which is react with ethanol chloride or acetyl chloride in presence of pyridine. So, to form the salt molecule first this N plus and CO minus CH3Cl, and finally they form C2H5 NHC double bond O CH3 means one hydrogen atom of amine replaced by C double bond O CH3 group, and to form this compound N ethyl ethanamine. So, N ethyl ethanamine, and this N ethyl ethanamine, this is the product of acylation of amines. So, primary amine they gives N ethyl ethanamine, but secondary amine, for example CH3NH C6H5, they are called N methyl aniline. So, this is the example of secondary amine which is react with acetyl chloride or acyl chloride or ethanol chloride in presence of pyridine. So, this one hydrogen atom of amine replaced by this acetyl group, and to form N methyl N phenyl ethanamide. So, to form N methyl N phenyl ethanamide. So, this is the molecule of ethanamide, and two alkyl or aryl group attached to nitrogen atom. So, N methyl N phenyl ethanamide. But in this acylation of amines, tertiary amine they cannot form acylation reaction because of they having no any replaceable hydrogen atom on nitrogen atom. Then next chemical property carbylamine reaction. So, carbylamine reaction means in this reaction aliphatic or aromatic primary amine on heating with chloroform gives foul or offensive smell product, and this product is called as alkyl or aryl isocyanide or carbylamine. Hence, this reaction is called as carbylamine reaction. So, this reaction is test for the primary amines. So, carbylamine test is useful for the detection of primary amines. Secondary and tertiary amine they do not use this test. So, for example, RNH2 means primary amine which is react with chloroform and 3 molecules of KOH on heating they gives RNC means alkyl isocyanide, or they are also called as alkyl carbylamine, plus 3 molecules of KCl plus thrice H2. These are the side product of this reaction. So, this test is given by only primary amine. Secondary amine and tertiary amine they do not use this carbylamine test. So, some MCQ based on this carbylamine reaction. Number 1, which of the following amine will give the positive carbylamine test? First option dimethylamine, this is the example of secondary amine. Trimethylamine, this is the example of tertiary amine. Option C methylamine, it is example of primary amine, and option D diethyl ether, this is the example of ether molecule. So, out of these 4 option we have studied in carbylamine reaction only primary amine gives this test. Hence, the correct option is option C methylamine. Second option or second MCQ, the carbylamine reaction is also known as option A Hofmann's elimination reaction, Sandmeyer's reaction, isocyanide test, and D Wittig reaction. So, out of these 4, this carbylamine reaction they are also called as isocyanide test. So, the correct option is isocyanide test. Next chemical property reaction with nitrous acid. So, in this reaction fen primary amine means RNH2, which is react with HNO2, nitrous acid, and this nitrous acid they form from the NaNO2 and HCl. So, sodium nitrate which is react with hydrochloric acid and to form this nitro acid. This reaction is carried out in ice bath at the temperature 273 to 278 Kelvin. So, in this reaction the formation of, in first step, alkyl diazonium chloride. This is the molecule diazonium salt. They are called as diazonium salt. Di means two molecule of nitrogen atom. So, diazonium, azonium is positive charge and chloride. So, alkyl diazonium chloride, and this alkyl diazonium chloride on hydrolysis reaction means addition of water molecule. So, in this reaction the replacement of diazo group by OH group and to form alcohol by removing nitrogen gas and hydrochloric acid. So, in reaction with nitrous acid and primary amine, in first step the formation of diazonium salt or alkyl diazonium chloride, and which on hydrolysis they gives alcohol. But the aromatic primary amine they react with nitrous acid, they form benzene diazonium chloride, and this benzene diazonium chloride which on hydrolysis they gives phenol molecule. Means aliphatic amine they convert into aliphatic alcohol, and aromatic amine they convert into phenol molecule. So, this is the example of aromatic primary amines, means aniline. Aniline react with nitrous acid at 273 to 278 Kelvin in presence of NaNO2 and HCl. They, in first step the formation of benzene diazonium chloride means diazonium salt, and this diazonium salt on hydrolysis they use phenol. This aryl diazonium salt are resonance stabilization and the useful as a versatile intermediate to obtain the variety of product. This N triple bond N. So, this is a diazonium group, and this diazonium group they form the resonance stabilization and to formation of this structure. So, the positive charge create on ortho and para position. So, any other nucleophile added to this ortho and para position of diazonium group. So, look at this structure reaction of diazonium salt. In last chemical property the formation of benzene diazonium chloride or diazonium salt, and these are the reaction or diazonium salt reaction they including in diazonium salt by removing the azo group. So, this is the first reaction, Sandmeier's reaction, and this Sandmeier's reaction the substrate this ArN2X minus means diazonium salt or benzene diazonium halide, and this benzene diazonium halide which is react with these three reagents CuCl HCl, CuBr HBr and CuCN KCN. So, these three reagent, and in this reagent three azo groups means in this reaction the azo group replaced by chlorine atom, bromine atom and cyanide, and to form ArCl means chlorobenzene, ArBr means bromobenzene and ArCN means cyanobenzene. So, in Sandmeier's reaction diazonium molecule they convert into chlorobenzene, bromobenzene and cyanobenzene, and this reaction is called as a Sandmeier's reaction. Second reaction of diazonium group, Gattermann reaction. In Gattermann reaction by using the copper powder and HCl and HBr. This method is also formation of halobenzene like chlorobenzene and bromobenzene, and this reaction is called as a Gattermann reaction, and this diazonium group replaced by chlorine and bromine by removing of nitrogen gas or removing of diazo group. Third reaction, iodobenzene formation. So, iodobenzene it is also example of haloarenes, and in this reaction potassium iodide which is react with diazonium group, and this diazo group replaced by iodine atom and to form ARI means iodobenzene. Next reaction, mild reduction of this diazonium group. So, ArNH2Cl means diazonium salt or diazonium group they react with H3PO2 and water molecule, and in this reaction the hydrogen atom attached to the benzene ring and to formation of ARH means benzene molecule by removing N2 plus H3PO3 plus HCl. So, in this reaction, the one hydrogen atom from water molecule, they attach to aromatic ring and the formation of benzene ring from diazonium salt. In second reaction also, this diazonium salt, which is react with ethyl alcohol CH3 CH2OH. So, in this reaction, they also formation of this one hydrogen atom of oxygen, which is attached to aromatic ring and to form ARH molecule. So, this method, the mild reduction method, is useful for the formation of benzene from diazonium salt. And the last one, phenol formation, last we have already may discuss. In last reaction, we have already discussed this formation of phenol, this diazonium chloride, which is which on hydrolysis reaction at 283 Kelvin, the formation of phenol molecule means AROH. Reaction with fluoroboric acid. So, arene diazonium salt on a reaction with fluoroboric acid gives the precipitate of diazonium fluoroborate, which on heating the decompose to yield fluoroarenes. So, this method is useful for the preparation of fluoroarene or fluorobenzene. In last reaction, we have discussed the formation of chlorobenzene, formation of bromobenzene, formation of iodobenzene, but this formation of bromobenzene by reaction with fluoroboric acid and this diazonium salt, which is react with fluoroboric acid HbF4, they form ArN2BF4. This is the salt molecule, and this salt molecule on heating they are gives ArF means fluorobenzene, and by removing of N2 and BF3. This molecule also heating with the copper and in aqueous NaNO2 they form nitrobenzene. So, this diazonium chloride or benzene diazonium chloride, they react with fluoroboric acid, they form this salt molecule, and this salt molecule on different reaction, which one in which in first reaction on heating they gives fluorobenzene, and in second reaction they react with NaNO2 copper, they gives nitrobenzene. So, in this reaction, when benzene diazonium chloride, which is react with phenol in presence of base, they form para hydroxy azobenzene. So, this OH group present on para position, so they are para hydroxy azobenzene. So, this is the formation of para hydroxy azobenzene. In second reaction, benzene diazonium chloride, which is react with aniline in presence of base, they form para amino azobenzene. So, the difference between these two structure, in first structure OH group present on para position, in second structure amino group present or para position. So, the formation of the displacement of azo group by this phenol and aniline molecule, and the formation of para hydroxy azobenzene and para amino azobenzene. The next reaction and most important reaction in this chapter, the reaction with arene sulfonyl chloride, and this reaction is called as a Hinsberg test. So, in Hinsberg test, the benzene sulfonyl chloride C6H5SO2Cl, this is the structure of benzene sulfonyl chloride, benzene react with S double bond O Cl, and this benzene sulfonyl chloride which is react with primary amine, and for example C2H5NH2 means ethyl amine, and this ethyl amine react with benzene sulfonyl chloride, this chlorine atom they replace by NH(C2H5) group and to form N-ethyl benzene sulfonamide molecule. So, this is the structure of benzene sulfonamide, N-ethyl benzene sulfonamide molecule, and this N-ethyl benzene sulfonamide molecule, they are soluble in alkali like NaOH or KOH. So, this is the reaction of Hinsberg test. Another example, when secondary amine which is react with benzene sulfonyl chloride, this one hydrogen and chlorine atom they replace, and this N nitrogen atom attached to this sulfur atom and to form N-ethyl. So, NN diethyl benzene sulfonamide. Sulfonamide, it is a similar structure with the amide molecule, hence they are called sulfonamide. But this NN diethyl benzene sulfonamide does not contain any hydrogen atom attached to nitrogen atom, hence it is not acidic and does not dissolve in alkali. Primary amine react with benzene sulfonyl chloride, they form N-ethyl or N-alkyl sulfonamide molecule. They having one hydrogen atom present on nitrogen atom, hence they are dissolved in they are acidic in character and dissolve in alkali, but this secondary amine react with benzene sulfonyl chloride and the formation of N-diethyl benzene sulfonamide. They do not having any hydrogen atom on nitrogen atom, so it is not acidic in character and they do not dissolve in alkali. And tertiary amine, they do not react with this benzene sulfonyl chloride because of they do not having any replaceable hydrogen atom on ammonia. The electrophilic aromatic substitution in aromatic amines. The first electrophilic reaction, bromination. So, bromination means addition of bromine by replacing the hydrogen atom from aniline. So, in this example, this aniline react with 3 molecules of bromine, or they react with bromine water Br2 in H2O, and in this reaction 3 hydrogen atom, 2 from ortho position and 1 from para position. These 3 hydrogen atom replaced by 3 bromine atom and 2 form 2,4,6 tribromoaniline, and this the precipitate of this 2,4,6 tribromoaniline, it is a white in color. So, the white precipitate of 2,4,6 tribromoaniline. Second reaction, nitration. So, in this reaction, when aniline which is react with nitrating mixture like concentrate solution of nitric acid and sulfuric acid at 288 Kelvin, it gives a mixture of ortho, meta and para compound. So, in NO2 group attached to the para position with respect to this NH2 group, they form para nitroaniline and they having highest or major product is they having 51% product para nitroaniline. So, this is the major product. Second molecule, they are also second possibility, this nitro group attached to the meta position and to form meta nitroaniline, they having 47%, and least or minor product is ortho nitroaniline. This NO2 group attached to ortho position with respect to this NH2 molecule due to the steric hindrance or atoms crowding, aniline is formation by using this acetylation reaction. So, we get the para nitroaniline as a major product. So, NH2 group is first protected by acetylation reaction. So, this CH3CO twice O means acetic anhydride in pyridine. So, in first reaction this NH2 group is protected and this one hydrogen atom replaced by this acetyl group to form acetanilide. So, in this first step the protection of NH2 group. In second step, acetanilide which is react with nitrating mixture at 288 Kelvin, this nitro group attached to para position, and finally in third step this removing of acetyl group by react with H plus ion or acid and base, acid or base to form the removing of this acetyl group and this NHC double bond OCH3 group, they convert into NH2, and this is the only one major product formation in this reaction, para nitroaniline. So, this is the reaction of nitration. So, in sulfonation reaction, aniline react with sulfuric acid and they form anilinium hydrogen sulfate, and this molecule on heating at 453 to 473 Kelvin, they gives sulfanilic acid. So, this SO3H group, they attach to this para position sulfanilic acid, and this sulfanilic acid they are spontaneously convert to each other. This one this hydrogen atom from sulfonic group, they are attached to this NH2 molecule and the formation of NH3 plus and SO3 minus. So, both ions, positive ion and negative ion, they present in only one molecule and they are called as a Zwitter ion.